So in the past, we've already evaluated radicals, right? We took like the square root of 25, and we talked about how since 5 squared equals 25, and the square root of 25 is 5, it's just the inverse, right? We did that with cubed roots and fourth roots. Today we're going to see what happens when you have a radical that doesn't come out evenly. Here's an example. If I have the square root of 50, right? There is not an integer, a whole number, we can square to get the square root of 50. We know 7 squared is 49, so it's got to be pretty close to 7. And we could plug this in the calculator. It's going to be 7 point something. So since it's an irrational number like we talked about before, what we're going to focus on today is even though I can't evaluate it, I can't get an answer, at least without approximating or rounding it off, we can take the square root of 50 and simplify it. So that's what we're going to do right now. The way we're going to do that is by looking at its factors. So if I take 50, I want to get a list of its factors. The way I'm going to do that is by making a factor tree. So let's see, 50, I got 5 and 10. 5 doesn't break apart. So we get down to here, that is a list of all its prime factors. So I'm going to come back over here, I'm going to rewrite it, square root of 50 as being square root of 5 times 5 times 2. And I put those 5s together on purpose. Okay, what happens next is there's a rule, it's called the product rule for radicals, and it says if I have the square root of a times b, it's the same thing as the square root of a times the square root of b. So I can take those radicals and those square roots and split them apart. So what we're going to do here, right, is we're going to split this apart. I'm going to go square root of 5 times 5 times the square root of 2. And the reason why I did that is because over here I end up with the square root of 5 squared. And this one right here, right, 5 squared is 25, the square root of 25 is 5. We talked about this, right, the square root and a square are inverses. So that part just comes out to be 5. The square root of 2 I cannot simplify. So there's my answer, right? 5 square root of 2, 5 times the square root of 2 is exactly the same thing as the square root of 50. If you plug them both into a calculator, square root of 50 comes out to be 7.07, with a lot of decimals. It's irrational, so that will go on forever. If you plug in 5 square roots of 2, it comes out to be exactly the same thing. So these two are equivalent to each other, but this is a simplified form down here. We talked about with fractions, right? When you take a fraction, we always put it in a simplified form. Well, that's the way it's going to be with radicals also. And we're going to take it and write it in its simplified form. Let's look at another example. Square root of 16, we don't need to spend time on that, right? We know square root of 16 is 4. That one is not irrational, so we can just evaluate it and get the answer. Now let's do this one, the square root of 288. So this is a lot bigger. We need to come up with its factors. So let's take 288. 2, and I know 2 goes into it, I think 144 times. 144, I know that one, that's 12 and 12. That would be 2 and 6, 2 and 3, 2 and 6, 2 and 3. What I'm looking for is I want all the pairs of factors. So if I look up here, I've got a 2 and a 2. That's a pair of factors. I'm going to put those up here. So it's the square root of 2 squared. If I find another pair, I've got one right here. Let's see, I've got 3. Got those 3's right there. So there's another pair of factors times by. And then I've got these 2's right here. That's another pair of factors. And the very last one is I've got this 2 right here. It does not have a pair. So I'm going to leave it on. I'm going to leave it just by itself. Okay, what happens here, right? I have the square root of 2 squared. That's just 2. Times by square root of 3 squared. That's just 3. Times by the square root of 2 squared. That's just 2. And then I've got this 2 right here. It's also inside the square root. I cannot simplify it. It does not simplify outside of the square root because it does not have a square, so it just has to stay the same. Okay, my final answer, 2 times 3 times 2 is 12. So there's my simplified form. Okay, 12 square roots of 2. By the way, if I come back up here, if I had noticed right here that I had a pair of 12s, I could have just stopped right there and left it as 12 squared times 2, right? And that comes out to be 12. That's a little simpler. So if you do go along the way, even if you haven't factored it all the way, but you notice you have a pair of factors, you can stop right there. And I'm going to put another one up here. I want you guys to give it a try. So pause the video, give it a try, and then I'll go through it with you. So it's the square root of 112. All right, so hopefully you've worked down through that. 112 again. I know 2 goes into it because it's even, so it'd be 2 and 56, I think. 56 breaks apart to be, what, 7 and 8. 8 breaks apart to be 2 and 4. 4 breaks apart to be 2 and 2. Okay, so I'm looking for a pair of factors. I've got 2 and 2, and I've got those 2's right there. So I'm going to come over here. Square root of 112 is 2 squared times 2 squared times 7. Hey, that square root of 2 squared is 2. I get a 2 on the outside. Square root of 2 squared, again, they cancel out. That's 2. Square root of 7, there is not another square root of 7, so it just stays inside of there. 2 times 2 is 4, so we end up with 4 square roots of 7. And that's pretty much it. All we're doing is just practicing breaking it apart. Again, you're looking for those pair of factors. Let's just try one more. So again, pause the video, simplify this, then I will go I'll kind of work down through it and you can compare your answer. All right, so 175. Use your good division skills. We know that because it ends in 5, 5 will go into it. So 5, I'm not sure how many times. I'm going to grab my calculator. So 175 divided by 5 comes out to be 35. 35 comes out to be 5 and 7. And again, what I'm looking for is pairs of factors. So I have 5 and 5. So I'm going to come over here. I have the square root of 5 squared, and I also have that 7. Okay, square root of 5 squared, that comes out evenly to be 5. Square root of 7 does not. It's irrational. So square root of 175 is the same as 5 square roots of 7. And be aware that sometimes they don't reduce. Here is an example. If I have the square root of 10, right, 10 is 2 and 5. So I guess you could break it apart. The problem is I can't take the square root of 2 and I can't take the square root of 5. Neither one has a pair, so it does not come out evenly. So we have to just stop there. So really the answer, go back up here, times those back together. The answer is the square root of 10. And that's all we're doing on this assignment. We're just going through and practicing simplifying these radicals down as far as we possibly can. Thanks, guys.